Problem 14030-105. Determine all the roots of, real or complex, of the system of simultaneous system. X plus y plus z equals 3. X squared plus y squared plus z squared equals 3. X cubed plus y cubed plus z cubed equals 3. USA Mathematical Olympiad, 1973.
We are given a system of 3 equations. X plus y plus z equals 3. X squared plus y squared plus z squared equals 3. X cubed plus y cubed plus z cubed equals 3. One very effective method for solving such systems, especially when the equations involve sums of powers of the variables, is to relate these sums to the elementary symmetric sums.
The elementary symmetric sums for 3 numbers x, y, and z are defined as E sub 1 equals x plus y plus z. E sub 2 equals x y plus yz plus zx. E sub 3 equals xyz. Our goal is to find E sub 1, E sub 2, and E sub 3, because once we have these, we know that x, y, and z are the roots of the cubic equation. T cubed minus E sub 1 ton squared plus E sub 2t minus E sub 3 equals 0.
Step 1. Find E sub 1. The first equation directly gives us E sub 1 equals 3. Step 2. Find E sub 2. We use the relationship between the sum of squares and the first 2 symmetric sums. X squared plus y squared plus z squared equals the quantity x plus y plus z squared minus 2 times the quantity x, y plus yz plus zx.
Substituting x plus y plus z equals 3, we get 3 equals 3 squared minus 2e sub 2. Since we are given that x squared plus y squared plus z squared equals 3, we set up the equation 3 equals 9 minus 2e sub 2. Solving for e sub 2. 2e sub 2 equals 6. E sub 2 equals 3.
Step 3. Find E sub 3. Next, we use the formula for the sum of cubes. X cubed plus y cubed plus z cubed equals the quantity x plus y plus z cubed minus 3 times the quantity x plus y plus z times the quantity x, y plus yz plus zx plus 3x, y, z. Substituting the known values. 3 equals 3 cubed minus 3 times 3 plus 3 e sub 3. This simplifies to 3 equals 27 minus 27 plus 3 e sub 3. 3 equals 3 e sub 3. E sub 3 equals 1.
Step 4. Form the cubic equation. Now that we have E sub 1 equals 3, E sub 2 equals 3, E sub 3 equals 1. The cubic polynomial whose roots are x, y, and z is t cubed minus 3t squared plus 3t minus 1 equals 0.
Step 5. Factor the cubic equation. The cubic polynomial t cubed minus 3t squared plus 3t minus 1 can be recognized as a perfect cube. The quantity t minus 1 cubed equals t cubed minus 3t squared plus 3t minus 1. Thus, we have the quantity t minus 1 cubed equals 0.
Conclusion. Since the only solution to the equation t minus 1 cubed equals 0 is t equals 1, it follows that x equals 1, y equals 1, z equals 1. Request. If you liked this video, please like it. I would appreciate it if you subscribe to the channel for more videos.